This is Rocco Boxer, and today we're going to calculate how much heat is required to heat up our hot tub, how long that hot tub will take to heat, and then how much propane will it take to heat the hot tub, and how much will that cost us. So here we have a picture of a hot tub with a heater and some lines running in and out of it. It goes through and heats the water, returns it to the hot tub, and that cycle, this is putting it back in here, that cycle requires some energy, and we can calculate that energy with the following equation. So when we have what we call Q ideal, that's how much heat it's going to take to heat this water, is going to equal the mass of the water times the heat capacity of the water times a difference between the final temperature and the temperature we start at. We'll call that Ti. So here, this Q is going to be in the units of BTUs. The mass is going to be in the units of pounds. Heat capacity is going to be in the units of BTU per pound degree Fahrenheit. And of course, the temperature units are going to be the degree Fahrenheit. If you do all the unit cancellations here, you'll see pounds cross out, Fahrenheit cross out, you have BTU equals BTU. Okay, so let's plug in some numbers. Before we do that, the first thing we have to do is calculate the mass. And the mass of the water in that tank or hot tub is going to equal the volume of the hot tub times the density of water. And the density of water is 62.4 pounds per cubic foot. And the volume is going to be in probably either gallons or we need cubic feet, so we're going to just put cubic feet. If you should have the capacity of your hot tub in gallons, then we know that the volume, what you need to do is take the volume in gallons and divide it by 7.48 gallons per cubic foot, and then you'll have cubic feet, okay? Very simple calculation, so we'll call this volume cubic feet equals that, okay? And then if you don't have your gallons, or you don't know what the capacity of your hot tub is, I'll have a second little part of this video to show you how to calculate it based on some measurements of your hot tub. You can come up with the cubic feet pretty simply. But for us, we're going to assume that volume for ours is 550 cubic feet. Let me just clean that up a little bit. So it was kind of sloppy. It is 550 cubic feet, okay? So we have that, and we know the pounds per cubic feet. So we know the mass of our hot tub equals 550 times 62.4. And that equals 4,588 pounds of water, okay? Now, we've got the mass. Now we have to know the heat capacity. Well, the heat capacity of water is kind of cool. It's 1 BTU per pound degree F, okay? And that is the heat capacity of water, so it's nice to use these English units because it's 1, so that's super easy to calculate. And let's say we're going to take we're going to start out at 74 degrees Fahrenheit. We're going to bring that up to 104, which is a typical hot tub temperature. So that is 30 degrees, okay? So we have to take this to find this Q ideal. We're going to take all these numbers, which is 4588 times 1 pound, 1 pound BTU, I'm sorry, 1 BTU per pound F, okay, times 30. Shouldn't have even done the units there. You know what they are. It's 1. So that is going to equal 1,300 or 137,647 BTU. Okay, so that we got our first thing. We know in an ideal world with no heat loss, nothing, it's going to take 137,647 BTUs to heat this water. But we know we don't live in an ideal world, and we have to now understand what our actual heat is going to be, and that is going to equal our ideal heat divided by the efficiency of the heater. Okay, we'll call it. We'll use that symbol there, and I'm going to assume it's about 70% efficient, which is probably high, but perhaps it's a warm day, the ground is warm, we don't have a lot of losses there, and maybe it's a short run between the heater and the in the jacuzzi or the spa. So we'll just call it 70%. So our actual heat is going to equal 137,647 divided by 0.7, and that is going to equal 196,338 BTU. All right, now we know that. So for just all purposes, we're just going to call it, we're going to round it and just say it's 200,000 BTUs. Makes it a lot easier to calculate, and we know we're in the ballpark. Now we're going to look at the work that the heater does. And in order to do that, we have to take the actual heat that we have to put in divided by the heater rating. My heater rating is 450,000 BTU-H, which is BTUs per hour. So if you take our number of 200,000 and divide it by 450,000, you can do it with shorthand like this. We get that the work that we need to do is, it's going to take 0.36 hours of work at that heat capacity, at that heat rating, to generate 200,000 BTUs of heat. So 0.36 hours, and if you multiply that by 60, you get about 22 minutes. Okay, so 22 minutes, you want to go in your hot tub, it's sitting there, you know your volume, it's sitting there at 74 degrees. You want to bring it up to 104, you got 22 minutes, okay? Now, what does it cost to do that? So if we scroll up a little here, let's calculate the cost. So we know that the cost is going to equal the amount of heat we need divided by the heating value of propane, and I'll talk about that in a second, times the cost per gallon of propane. Okay? This heating value of propane is, I looked it up, there's 21,591 BTUs per gallon of propane. So if you have a gallon of propane, how much heat can you get out by burning it? It's 21,591 BTUs. So if we know our actual, which we called 200,000, and we divide it by 21,591, we'll put 200,000 up here divided by 21,591. Then we multiply that by the cost of propane, which is $2.10 a gallon by me. Then we will know how this will all come out into dollars. But what's interesting, let's see how many gallons of propane that's going to take. It's going to take, if you do this math, it's 9.26 gallons of propane. Okay? And then we're going to multiply that by 210. And so you get, what you come up with is about $19.45. Okay? So that is the cost that it takes to heat up your tank, heat up your hot tub. It's going to take about 22 minutes. You're going to spend about $20, and you're going to bring that up about 30 degrees. If it's colder out, it's going to cost you a little more. If it's warmer out, it's going to cost you a little less. If you cover your hot tub, that'll save you on your efficiency. That'll go up. If the efficiency goes up, the amount of heat you need goes down. And so, or if you have a longer run, then maybe your factor is not 0.7 on your efficiency, maybe it's 0.6. But that should get you some approximations. You could do that yourself. The next part of the video, I'll show you how to 3 ways you can calculate the volume of your hot tub, and I'll jump into that right now. Okay, so let's look at the volume calculations for the 3 different kinds of hot tubs. We have a round hot tub, a square hot tub, and an oval hot tub. So on the round one, you'll have a few different measurements. The height of the water to the lowest point, we're going to call capital H. The height from the seat to the surface, we're going to call little h. The distance across the hot tub, the radius of the hot tub, we're going to call r. And then the little distance in the bottom and the base, we're going to call little r. And if you want, you can, measure all the way across and divide by 2 to get your r. So what the volume of that round one is going to be pi times the height times the radius squared, and the height between the top and the bottom, and basically from this top, from the bottom of the seat to the bottom of the hot tub is going to be that big H minus that little h. And then if you multiply that by r squared, then you've got the bottom, you got the volume of the portion of the hot tub up into the seat. And then when you want to think about an upside down birthday cake, that's the top of the cake. Now we're going to get the bottom of the cake, which is from the seat to the surface across the whole hot tub. And that's going to just be that little h times r squared. So you got that. Now with a square hot tub, it's easy to calculate but kind of hard to draw. So let's imagine that you have some seats that go all the way around in that hot tub. The height, the big H, is going to be all the way to the bottom, the deepest part. The little h is going to be from the surface to the top of the seat. Big X is going to be the outside, X and Y of that square or rectangle. It would work the same way for a rectangle here too. And then the little yi and yx, what I'm trying to show here is that's for the bottom part where your legs go, right? So that's a little rectangular box, and the other part, the top part, is a big rectangular box. And so this is how you calculate that. Very similar with the h minus h, same kind of calculation there, and then times your square or rectangle dimensions. And then if you have an oval type hot tub over here, number 3, that's the oval, that's simple. It's just the distance across each length, the length and width, multiply those, and then times that by pi, and then figure out how deep your hot tub is. So this would be from the surface, the surface to the bottom here. And that would be that one. So that's how you can calculate your volume. And then, you go from there with my calculations from the previous part of the video, and you've got it covered. So if you have any questions, go ahead and leave them in the comments. I'll get back to you. And I hope you enjoyed the video, and maybe this is kind of fun to do if you have a hot tub and you want to know what it's costing you to heat it up, and maybe how long it'll take. Okay, this is Rocco Boxer. I would really appreciate if you could like the video, add a comment, and then also subscribe to this video to see other videos that I'll do is on either scuba or droning or some physics problems. Soon I'll have a video up on the Raptor Assault class I recently attended. So if you like all that, then just subscribe, and we'll make sure you get to see all the videos I put out. Thanks again.